Okay, guys, I'm gonna go through this pretty quickly, so hopefully it feels like review to you. We're gonna be doing a little bit of Pythagorean theorem, very little, and then we're gonna be kind of readdressing SOHCAHTOA from last year in geometry. So first thing we're gonna look at is like, how do we find the third side of a triangle if we know two of them? And we're gonna do that, by using a squared plus b squared equals c squared, where a and b are the legs that form the 90, c is the hypotenuse, which is always gonna be the longest side. We've done that, we know how to do that. Let's just quick refresh that. Here's a, b, don't know c, it's across from the 90, it's the hypotenuse. So c squared is gonna be my a squared plus my b squared. So c is going to be the square root, and then 3 squared is 9. 7 squared is 49. So c is going to be the square root of 58. It did say in this one to do exact answers, so I'm done. Here, this one's a little different because this is my a, b, c. C is across from the 90, and so I actually know my c. So c squared is going to equal a squared plus b squared. So I do have to slow down here a little bit because I end up having to do some subtraction. So 7.4 squared is 54.76, and 3.6 squared is 12.96. So I'm going to get that over to the other side. This is all stuff we've done in algebra, and also you have done this in geometry. So this should not feel like news. I don't have to do plus or minus because I am finding the length of a side, and it doesn't make any sense for the side to be negative. Okay, so we're going to get into some triangle stuff where you can't use Pythagorean theorem because you only know one side. And if you only know one side, maybe you also know an angle, then it's time for trig. So let's revisit the concept of SOHCAHTOA. Sine is opposite over hypotenuse, cosine's adjacent over hypotenuse, tangent is opposite over adjacent. So we knew that from before. Let's refresh our memories on what those sides are. If this is my angle, this symbol is theta. We use that a lot in Algebra 2 and higher to represent an angle. If you shoot straight across from that, you're going to get the opposite side. So that's always going to be across from the angle that you're talking about. The hypotenuse is always across from the 90. And so that one's easy to identify. And it's also going to be that longest side. And then the adjacent, I always kind of do that one last because it's the one that's touching the angle. So it's like next to that theta, but it's part of the legs that form the 90. So I always label it last because the easier ones are across from the angle and across from the 90. So you've done this relationship series before where sine is opposite over hypotenuse, cosine's adjacent over hypotenuse, and tangent's opposite over adjacent. That's where this came from. What's new this year is we're flipping them over. We're doing their reciprocal functions. This is called cosecant. It flips over the sign. So instead of being opposite over hypotenuse, it's hypotenuse over opposite. Secant goes with cosine. Those two are reciprocal functions. So instead of adjacent over hypotenuse, you put hypotenuse over adjacent. You just flip the fraction over. When you flip tangent over, you get cotangent. And instead of having opposite over adjacent, you have adjacent over opposite. We don't really use those to solve any triangles or anything, but we are going to start being asked that as you get into college algebra and into pre-calculus, which is, the classes that are next for you guys. So we want to start talking about those. So we know how to do this stuff from last year, find the missing side, and then we're going to figure out how to do this from this year. We know how to do these three: opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. Then what we're going to do is flip these over and get our reciprocal functions. Cosecant, hypotenuse over opposite, hypotenuse over adjacent for secant, and adjacent over opposite for cotangent. So we just got to find all the sides. This is the opposite side. This is across from the 90, so that's my hypotenuse. This is going to be my adjacent side, but I first have to get that number And so I'm just going to use Pythagorean theorem to find that third side. So I know that 17 squared is 289, and I know that 15 squared is 225. When I subtract that 225, I end up with a 34. So that unknown side is root 34, and it does say exact values, so I'm going to have to leave it as a square root. So now I'm just going to start putting these three numbers that I got, and I'll write it down here, in their proper spots. So sine is opposite, which is 15, over hypotenuse, which is 17, and I'm done. For cosecant, I'm going to flip that over, and I'm done. Now it gets kind of ugly because cosine is going to be my adjacent over hypotenuse. That's fine. But when I flip it over, it gets kind of gross because now I'm going to have 17 over root 34. Cannot leave that in the bottom. So we're going to do what you've learned to do in several classes, which is rationalize it. And then when I do rationalize it, I got to check these numbers on the outside to see if they reduce. And in this particular one, they do, and they reduce to 1 over 2. So my final answer is root 34 over 2 as that ratio of hypotenuse over adjacent. Yuck. Tangent, if I look at my triangle, has to be opposite over adjacent. Well, opposite is 15, adjacent's root 34. I'm going to go ahead and flip that over right away. So my root 34 over 15 is done, and that's fine. Then I'm going to go ahead and rationalize this one. So I'll get 15 root 34 over plane 34, and the 15 and 34 don't reduce, so I'm done. Some of you will get good at just doing the rationalizing in your head, and you'll be able to skip right from here to here. That will be helpful, but not necessary. So how are you going to be using this? You're going to be using this to find missing sides. So like here's my angle. That makes this the opposite. Here is my 90. That makes this hypotenuse. So if I'm trying to find this unknown side, I'm looking at the two pieces involved, opposite and hypotenuse, and that says I need to use the SO part of SOHCAHTOA. So I set it up as the sine of 67 equals the opposite over my hypotenuse. I can always throw this down over a 1. You might have done it like that in geometry. Cross multiply, I get 8 equals C times sine 67. But if I divide that sine 67 out, I'll be able to find just the C value that I'm looking for. So on my calculator, I'm doing 8 and I'm dividing it by the sine of 67, and I'm coming up with about 8.7 as my length for the hypotenuse. And that is longer than the other side, so that's good. Here, same process. This is going to be my opposite side. This would have been my hypotenuse, and it's not labeled or involved. So this is going to be the adjacent. So the two things involved are adjacent and an opposite. So I'm going to be using the TOA part of my trig. So the tangent of 59 degrees equals opposite over adjacent. You can still throw down the 1 and do cross multiplying, but when the x is on the top, it's easier to just multiply the 20 up, 21 in this case. And then on my calculator, I'm just doing 21 times the tangent of 59, and I'm getting an x value of 34.9. Oh, it says hundredths, so technically 34.95. Okay, this is asking me to find two things. And so I have to label my triangle and say, all right, this is the angle, so that's going to be opposite. This is across from the 90, so that's hypotenuse. And this is the other side, so that's adjacent. If I'm trying to find two things, I'm going to have to set up two things. So we know this, we'll use that in both. And then let's say we're going to find this one. Opposite and hypotenuse means to use the SO part of SOHCAHTOA. So sine 50 equals opposite over hypotenuse. And I can just do the 10 up to both sides. All of this is stuff you did in geometry, so this should feel pretty familiar. B has a length of 7.66. Now, when I go to solve for A, which is adjacent, I still have to use the other thing I was given, which is the 10. So now I'm doing adjacent and hypotenuse, so I'll need to choose cosine. So the cosine of that 50-degree angle is the adjacent side, which is unknown, over the hypotenuse, which is 10. So same math, I'm multiplying, but this time it's 10 times the cosine of 50. And then my A is 6.43 if I'm rounding to the hundredths. So if you have to find more than one side, I could have found the last one using Pythagorean theorem, but I actually sometimes think it's just easier to do the trig way. Okay, two more ways you're going to have to use this. One is when they don't give you a triangle, it might be helpful to draw one. I don't really care what it looks like. I just know it needs to be a 90 and have a theta. Tangent is TOA, right? That's the TOA part. So this is my opposite over adjacent. So here's the opposite side. That's going to be 7. And then this is my adjacent side, which is going to be 12 because it says so. This is my hypotenuse, which I don't know, but I can find the hypotenuse using Pythagorean theorem by taking the square root of the a squared plus the b squared. I end up with a pretty hideous answer of square root 193, but whatever. I do have to give exact values, so I leave it as that. So now I have my three numbers. Opposite 7, adjacent's 12, hypotenuse is root 193. So when I go to do opposite over hypotenuse, I'm going to have 7 over root 193. And you kind of want to get to the place where you're like, oh, I'll need to do the top and bottom by root 193. And in this case, the 7s do not cancel because when I'm multiplying by the roots here, this is where I'm started getting that. The 7 and 193 don't reduce, so I'm done. And then here, I'm going to flip over what I started with and put the root 193 over the 7 and just be done. I don't have to rationalize. So I always flip over the thing from the very beginning. So cosine is going to be my adjacent over hypotenuse, which is 12 over root 193. So if I'm going to rationalize that, I'll be bringing up the root 193. The root 193 will cancel itself out. The 12 and the 193 on the bottom do not reduce. And then I flip over the original thing to get my secant. My tangent they gave me in the problem, they said it's 7 over 12. Then I flip it over to be 12 over 7. So that one's actually super easy compared to the other ones. Okay, last thing. Word problems. You're going to have a right triangle because it says right triangle math. So everything they're talking about is going to be a right triangle. Angle of elevation, think about what it means to elevate something. It means to lift it up. So you'll be going up from the horizon, meaning from the straight across. So my angle would be like that. Angle of depression, if you think about depression, it brings you down. And so it's going to come down from the horizon. So a lot of times they'll be like, oh, you're here cruising in your airplane. Angle of depression is how far down you go as you start to as you start to land. So how does that look in a problem? You're skiing on a mountain with an altitude. Altitude is how high up you are, so that'd be 1,200 meters. The angle of depression, so here's the horizon. You're coming down from that angle of depression, so that's going to be 21 degrees, it says. And then it's asking how far down the mountain do you ski, like how long are you actually going? And so that's that motion right there. What's tricky is the 21 degrees is outside the triangle. But from geometry, we learned that if you have kind of the Z shape going on with the alternating interior angles, you're going to have this angle out here be the same as this angle in here. So this is in the triangle and it's 21. Across from that makes this the opposite. Across from 90 makes this the hypotenuse. Opposite and hypotenuse means I'm going to need to use sine. So I do the sine of my angle equals my opposite side over the hypotenuse. And I'm going to go ahead and do my cross multiplying. And this is one where I end up having to divide that sine 21 out because my x was on the bottom initially. So this side just cancels, And on my calculator, 1200 divided by the sine of 21 tells me that sliding down the side of that mountain is 3,348.5 meters. And it should be longer than the other information because it's the hypotenuse. Zoom, grand finale. You want to build a skateboard ramp. Okay, here's a ramp. It's 14 feet long. Well, here's the ramp, so that's going to be the 14 feet. Angle of elevation, so that's up from the horizon, and that's 26. Find the length and the width. Okay, well, here's the length, length and height, and then here's the height. Well, this would be the opposite side, and this is the hypotenuse. So this bottom one has to be the adjacent. I'm trying to find two things, so I'll need two setups. First, let's use this to help us find the height. Okay, that's opposite and hypotenuse, so I'll need to use sine. So the sine of 26 equals opposite, which is unknown, over hypotenuse of 14. That's the easier kind where I can just multiply the 14 up. So 14 sine 26 means the height is 6.1 feet. And then when it's time now to find the adjacent, I still have to use the other given piece of information. But since I know adjacent and hypotenuse are involved, I'll have to choose cosine. So the cosine of 26 will be the adjacent, which is the length I don't know, over the hypotenuse of 14. And I just bring the 14 up to both sides. So you are just doing the same kind of math every single time, but you're just given the information in a variety of ways. Word problem, triangle, or like here where they gave you one of the features, you could draw a triangle and proceed from there. That's kind of the Algebra 2 version of it. Everything else, word problems, finding sides, you did do in Algebra 1 and geometry. And then this is also new, these second functions, those reciprocal functions. Hope that helps.